All right, so today we're going to be looking at, if I can get this back up here. Okay, never mind. It just erased everything. Uh, anyway, we're going to be looking at something called electron configurations. Really what we're going to be doing is we're going to be depicting where each individual electron is in relation to its spin and its, uh, what's the word I'm looking for? Energy level. So let's start off electron dot diagram for nitrogen. So I'll do a quick one up here. Nitrogen, if I wanted to do this, I would see that nitrogen is in row 1, 2. So that means nitrogen has 2 electron shells. Okay. That first shell, 2 electrons in it. So let's just go ahead and do 2 electrons in there. And that second shell, we normally would say we have 1, 2, 3, 4, 5 electrons. Oh, did that one a little bit out of order. But we're going to have it look the same as we would if we did it right. All right. So nitrogen, we see 1 pair of electrons, 3 unpaired electrons. Pretty easy. But this view doesn't really tell me how much information. It doesn't give me anything about these electrons. It just tells me where they're at. So with electron configurations, one of the things we're going to do is we're really looking at when we do these, if I could do this correctly. Trying to draw sideways with this thing doesn't work. Energy is going to, wow, that's really bad. Yeah, let's ignore that. All right. Energy increases the farther up we get. So let me try to fix this now. All right. There we go. All right. Energy increases as we're going to move up here. So then what gets tricky about these is knowing how much room you're going to need. So rather than drawing circles and stuff, really what we're going to do is we're going to depict what shell the electrons are in and what orbital they're in. So my goal is to get over here to nitrogen. So starting off with, I have row 1. Row 1, these 2 electrons, you colored both of those blue because those correspond with the s orbital. And then on your key, you wrote that that blue, that s orbital, gets 1 box. That becomes really important for electron configurations. That's really what that's meant for. So my job is to get here. So I have 2 electrons to put in these boxes. Now, rather than putting X's, I need to indicate their spin. And if you remember, when I blew your guys' minds, when I spun my arms in opposite directions, we are going to do the same thing right here. So essentially 1 electron goes up, the next electron goes down. All right, so now I'm down here, so I'm in row 2, and I'm going to start off with the s orbital. So right above where it says 1s, I'm going to put 2s, and the s's still get 1 box. And this box still has 2 electrons in it. My goal is to stop here, so I'm going through these 2. So let's go ahead, put those 2 electrons spinning in opposite directions. All right, so now I have these electrons here. You colored them red because these are p electrons. In this case, they're in row 2. So to indicate that, I'm going to indent in. I'm going to write 2p. On your key that you have written down, you say that p's get 3 boxes. So let's go ahead and do 3 boxes there. All right, so if my goal is to do nitrogen, that means I'm going to have 1, 2, 3 electrons in these 3 boxes. And I need to make sure every box has 1 electron in it before I double up. So I'm going to go 1, 2, and 3. So now you may ask, well, can't we double them up? No. Just like how we did with electron dot diagramming, each box needs an electron before we double up. All right, so let's do one that's a little bit harder. Let's do something like, let's do silver. I like silver. Iris start, chemical symbol here. Remember, a chemical symbol starts with a capital letter, and then everything else has to be lowercase, just like how it is on the periodic table. If you do both capital letters, that's nothing, and it's wrong. So my goal, I'm going to need to denote every electron in the rows going all the way down to this element right here. All right, so starting off with row 1. Row 1 has that s orbital in it. You wrote down the s orbitals gets one box. And in that box we have 2 electrons, so let's have them spin in opposite directions. Next we have row 2. We're going to start with the s electrons. 2s. S's still get a box. 2 electrons spinning in opposite directions. All right, so now I'm going to jump across here. I'm still in row 2, but now I have these p electrons here. So I'm going to indent in when I do 2p. The p's we said get 3 boxes. That looks long enough. All right, so now for 1, 2, 3, 4, 5, 6 electrons here. Let's start by putting 1 in each box. There's 1, there's 1, there's 1. And now let's double up. All right, so somebody's going to ask, do they all have to do you have to do it how I'm doing? Like I always start with the up arrows. And I'm going to say, no, you don't have to do that. So long as like when you start with the down arrows, they're all down before you start doing up arrows, okay? All right, so I'm done with that electron. So now I have these 2 here. I'm in row 3, and I'm starting with the s electrons. So let's go back. Essentially, I'm keeping my s's in a line. The 3 s's get a box. 2 electrons in it. Hopefully this will go faster for you guys. Jump across to here. I have these 6 p electrons. The p electrons get indented in. Let's go 3p because we're in row 3. The p orbitals, these guys here. P orbitals you wrote down get 3 boxes. And we have 6 electrons in there. You can count them if you want. But let's go 1, 2, 3, double up, 4, 5, and 6. All right. So starting here, 4s. So let's go ahead and put 4s right here. The s's still get 1 box. 2 electrons. All right, so now I need to do these electrons right in here. To do these electrons, you colored them green because they're d electrons, and you said that the d electrons go down a shell. So now for 3D, I'm not going to put 3D here. I'm actually going to go halfway between 3p and 4s, and I'm going to write 3D. All right, this D's, really what we're saying is that, so let's hold off on that for a second. So the D's you also say get 5 boxes. So 3D, see if I can fit 5 boxes in there. It's going to be tight, but I think I can do it. All right. Really what I'm depicting here is any electron that goes in here has more energy than what's in this 3p area, less than what's in the 4s. All right, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 electrons in here, so let's start with 1, 2, 3, 4, 5. Now I can double up 6, 7, 8, 9. That looks messy. 10. All right. So now I'm to here. With the p electrons, they stay in their row and shelf. So that means that these are 4p. Let's put my p's all in a row. 4p. P still get 3 boxes. And there's 6 electrons in there. Now I double up. All right, so now I'm in the row silver's in. So starting off with row 5, s orbital electrons. Let's go ahead and put those in a row. 1 box. There's 2 electrons in there. I know this is taking me a while. All right, so now I have these electrons here. Once again, you colored them green. They are d-orbital electrons. You also wrote down that d-orbital electrons go down a row. So in between the 5s and the 4p, let's go ahead and put not 5d, but 4d. The d-orbital electrons, 5 boxes. All right, so now silver, we're not going all the way through it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 electrons to put in these 10 boxes. So let's start 1 in each one. 1, 2, 3, 4, and 5. Now I can double up 6, 7, 8, and 9. So that's the electron configuration for silver. We can see that we have this one empty d-orbital electron space right there. That's important for something coming up pretty quick. With the F's, essentially, like let's say rather than doing, so that's silver. All right, so let's say instead of doing silver, I was doing, let's go with PR, promethium. Maybe if I knew that promethium started with the P. Okay, so now it's going to look pretty much the same. So we're going to have that, and that gets me through here, and then we're going to have the 5 P's, 3 boxes, 6 electrons, and if you can tell, I'm in a hurry now. All right, so now I got these two here, so these are 6s, 2 electrons in there. All right, so now when I go to do these you colored yellow, they're F orbital electrons, and you wrote that these go down 2 rows, right? So rather than being in 6, they're in 4, and I would put 4F right next to the 4D, but these we said are going to get, I'm going to have to get a little bit tricky here. Scroll over a bit. The S we say gets 7 boxes. Let's see if I can do that. 1, 2, 3, 4, 5. All right, it's a good thing we're only going to use 1, 2, 3 of these. So I have 3 electrons to put in there. 1, 2, and 3. All right, so now scroll back about right there. So this is promethium. Maybe I'll even put a PR right here. Really just those Fs, we just brought them right back down, put them right next to the 4Ds. I just want to show you guys where they were at. Your assignment, though, we're going to take these kind of one step at a time. But with that, good luck.